Okay, let's look at number 3 from section 2.2. And the question is, can you determine if the following quadratic function has a max or a min without graphing? And the answer should be yes. You're really going to focus in on the coefficient that's in front of that quadratic term. We talk about that as being our a. So when a is negative, you should know that that parabola is going to open downward, which means it's going to have a vertex that gives us a max whenever you have a parabola opening down. All right, if for some reason, not in this case, but you had a parabola that was opening up, let's say a was 3, then your vertex is going to be your lowest point, and that's where you're going to have a minimum value occurring. So part B, find the min or max and determine where it occurs. So we know that we're looking at a maximum because our parabola is opening down. The other thing that we should know is the axis of symmetry always goes through that vertex. So we can find the axis of symmetry by using x equals negative b over 2a. So in my quadratic function, it looks like b is going to be 6. And a, we already talked about, is negative 3. So I'm just going to plug in my values. So my b, I have a negative 6 all over 2a. So that's going to be x equals negative 6 over a negative 6, so x equals 1. So when you're thinking, on your coordinate plane, if you wanted to sketch, if this is x is 1, this is going to be your axis of symmetry, which means the vertex is going to be somewhere along that. And how do we find that vertex? Well, we know x is 1. So really what we're trying to find is our y value or f of x value. So I'm going to go to my function, which was f of x equals negative 3x squared plus 6 minus 13. And I'm going to now plug in 1. So I've got negative 3 times 1 squared plus 6 times 1 minus 13. So that's going to give us negative 3 plus 6 minus 13, which should give us a negative 10. So what that means is I'm going to have a vertex at, it looks like 1, negative 10. So we'll say it's right here. And remember, it's a parabola that's opening down. So when it says find the min or max, it's referring to the y value. So remember, I have a maximum. My maximum is negative 10. And if you were to graph this in your graphing calculator, you could kind of quickly look at your table, and you're never going to have a y value that's bigger than negative 10. So your maximum is your y value, and it occurs at x equals 1. So anytime you're talking about your max or min, it's looking for that y value. And then you can talk about where it actually occurs. Now, lastly, let's look at the domain. Anytime it's a quadratic function, when you're looking at a parabola that opens up or down, and assuming there's no restraint, your domain is always going to be, all real numbers. Because when you ask yourself, does my graph go left and right forever? It does. So anytime you're looking at just a typical parabola, your domain is going to be all real numbers. Okay, and then the last thing that we need to look at is the range. So here I have a sketch of my parabola. So ask yourself, I'm going to just write domain here, and then ask yourself on the range, what's your smallest y value? Well, since it's going down forever, it's going to be negative infinity. So I'm going to do this in interval notation. And think about then what's your largest y value? Well, remember that's your maximum. So it's going to be negative 10. Now it can equal negative 10, so you're going to put that bracket.